Welcome back to Geometry, Chapter 5, Section 3 of this book. We're going to talk about medians and altitudes of a triangle. Earlier today I said it too fast and it was like mediums, and I'm like, no, not mediums, medians. Medians. And so median means middle. It's sort of a fancy math word for middle. So what a median of a triangle is you take a side, you cut it in half, see these two are the same, and then you draw a line from that point to the pointy side across from it, the vertex. Notice this is not perpendicular, and it's just you cut this in half and then draw a line, and that's not angle bisectors either. We're just cutting it in half and drawing a line over there. So over here, we would cut this in half, say maybe right there, and draw a line. And this one we would cut in half, probably right there, and draw a line. All right, so we did it. Where they all meet together, meeting together in math is called concurrent. Where they are concurrent is called the centroid. So that is the centroid of that triangle. Now, it doesn't matter if the triangle is acute, all angles less than 90 degrees, right, one angle is 90 degrees, or obtuse, one angle is more than 90 degrees. The centroid is always inside the triangle. Okay? Now, notice I put balance point, and this is kind of fun. Here I have an illustration of this. I have a bird, and notice his shape is a triangle, and this point is the centroid of this bird. So he will balance on anything. You know, the end of a pencil, because it is his balance point. Whoops. If you go like that though, he can't balance anymore. Alright, so anyway, fun little toy. I can spend hours playing with my little centroid bird. That's him. But I found him. Earlier today I was like, going, where's my bird? Where's my balance point bird? It's the balance point. Okay, so guess what? We have a theorem to go with this. Of course we do. It's the concurrency of medians of a triangle theorem. And it is this, that if you do this, cut them in half and draw a line to the other side, this line, where this balance point, this centroid is, it is 2/3 of this line is on that side of the balance point, and 1/3 is on the other side of the balance point. So this one, that's the 1/3, that's the 2/3. That's the 1/3, that's the 2/3. So that's how it is. So this is what it's saying. From this middle point we're going to call P, and AP is 2/3 AD. BP is 2/3 BF, and CP is 2/3 CE. All right, so we can do some math with that. Here's an example. I have drawn the medians on there, and we are told that this line from P to T is 5. So what is from R to P? Well, if this is 1/3 and that's 2/3, then this is 5 and that is 10, because 10 is double 5. Does that make sense? So each third is 5. We have 2 of them here and 1 there. And the next thing is, what is RT? Well, 10 plus 5 is 15. Those aren't bad, are they? I kind of like these because I really like my bird. I like getting him out and playing with him when we do this lesson. Alright, so here's another one. And with this one, we have these points. 3, 6, 7, 10, 5, 2 on the coordinate plane. So we're graphing this. And they, we already know that this what the vertexes are. And they ask us, we know by looking at the graph that this line, if you look at it in your book, but this line is straight up, and we can count the little squares and see this is 4. And we can see that this is twice as big as that. So if this is 4, this is 2, and this whole line is 6. 2, That's not what we're looking at. That's 4, that's 2. Okay, so we're not there yet. All right, so then, so let me flip over and make sure what I wanted to teach you about it. So first of all, 5, 2, in, yes. So this point right here this was at 2, and now we add 6 more to it. N's coordinates are 5, 8. So their first question was, what are the coordinates of N is 5, 8, and what is the coordinates of P? And it's also on this 5 line. This is 2, 3, 4, 5, 6. So P right here is at 5, 6, and N is 5, 8. Now, with this, you can actually do these problems on your calculator if you have the distance program. It doesn't come on your calculator, but you can download it. There's places to find it. Or if you live near me, you can come by and I'll give it to you off of my calculator. But that's more fun doing it on the calculator than just looking at the graph and figuring it out. All right. So when you were in middle school, you learned about triangles, and you learned that they have a height. Well, sometimes that height is called the altitude. So like if you have a right triangle like this, that would be the height, by tradition written in cursive, okay? Or say it is a triangle, I'm going to erase that one. What if it's a triangle that looks like this? Then that's the height, that's the altitude. And sometimes they look weird, like that, and to get the height you have to drop a line that is perpendicular to the ground, and that is the height. Is all this coming back to you? Okay. So each triangle, you could turn it and do another height. Like if this was the base, that's the height. If this is the base, this is the height. If that's the base, then the height is like what that would be. Do you see that? So you can turn your triangle over 3 times and it would have 3 different heights. Okay? So if here I have a triangle and I have drawn a line from each side from the vertex down, you just drop a perpendicular. It's not a bisector. You just drop a perpendicular, a right angle, from the vertex to the side that is across from it. And each one of those is the height. This is the height if this is the base. That's the height if this is the base. That's the height if this is the base. Well, they will all meet in a place called, isn't this fun, the Orthocenter. There's something about that that sounds like it would be a place to go look at birds. Go to the Orthocenter and see the avian display. I don't know why. But it's not. It's not a bird zoo that I think it should be. It is the middle where they meet. Now, if it's a cute triangle, they meet in the middle. If it is a right triangle, see we drop one here, one there, it meets on the edge at a vertex. If it's a obtuse triangle, they meet way out here somewhere. But we have the theorem is the concurrency of altitudes of a triangle theorem, and it's basically that they're going to intersect somewhere, either in the middle, on the edge, or outside the triangle. They will intersect, the book says, at a point H. You don't have to call the point H, you can call it L for Lisa. Alright, so that is this idea. Hopefully you like it. Math is great. Maybe you can find a cool little balanced bird too, right? Alright, see you next time.